Hi science students, welcome back. Today we're going to deconstruct AKS 7F. Let's first read the standard. It says analyze and interpret data to explain the flow of energy during phase changes using heating and cooling curves. Let's first identify what the key terms are in this standard. So we're going to first mark our science and engineering practice of analyzing and interpreting data. We're going to also mark the flow of energy. We're going to also mark phase changes, which should sound familiar to us. And we're going to also mark heating and cooling curves. So let's go through and really dig into what each of these key terms really means so we know what this standard is asking us to do overall. Let's start with analyze and interpret data, and I'm going to do that with the color purple. I'm going to draw an arrow here, and I'm going to write that analyze and interpret data means to examine data. This could be any kind of data. So examining data. This could be data tables, this could be graphs, this could be numerical data that you're calculating, but you're examining some kind of data, and you need to be able to explain the meaning of that data. So I can look at the data given and I can explain what the data is supposed to be telling me. In this case, it's going to be about thermal energy. It's going to be about heating and cooling curves as the data source. But let's keep going. So let's look at the flow of energy. Let's dig into that one next. So I'm going to draw a little arrow up here for flow of energy. I'm using orange. And I'm going to write that the flow of energy really means the movement of the particles is going to change due to how much heat is applied or released. So I'm going to write the movement of particles will increase or decrease due to thermal, and I'm going to put in parentheses, kinetic. We know thermal energy is kinetic because those particles are moving as that thermal energy is applied. So the flow of energy is referring to the movement of particles will increase or decrease due to thermal kinetic energy, whether it's being applied and it's being absorbed or it's being released from that particular object. Either way, this refers to the flow of energy. So let's go on. Let's talk about the phase changes. And so I'm going to first write down what my states of matter are, that it can change from one phase to another. So I'm going to first write down solid, and then I'm going to write down liquid. And I bet you know what comes next. I'm going to write down gas. And let's talk about the phase changes in reference to the flow of energy. So as a solid gains thermal energy or absorbs thermal energy and turns into a liquid, those particles begin moving faster. That's what's happening. So I'm going to draw a little red arrow here, and I'm going to write heat is absorbed. This is what causes the bonds of that solid to break and break apart from each other and become liquid. The same occurs when a liquid transforms into a gas. Heat energy is being absorbed in this case as well. So let's talk about the opposite. As a gas transforms into a liquid, it condenses, thermal energy is actually being released. So we're going to write heat is released when a gas's particles begin to slow down and become a liquid. And the same occurs as a liquid begins to freeze. It begins to slow the movement of the particles and they draw closer together and they become that solid. They never stop moving, but as the liquid is changing to the solid, heat is being released. That's what's occurring, and that's what causes the freezing of that particular substance to occur. Let's lastly talk about heating and cooling curves. And we have begun talking about thermal energy, but heating and cooling curves might be something that's brand new to you. So a heating curve and a cooling curve are going to have similarities, but they're going to have distinct differences from each other. So I want you to start out just by drawing your X and your Y axis of two different graphs, and then draw an arrow from the heating curve and from the cooling curve so that you remember which one is which. So I'm going to draw on my lines, starting with my heating curve. So I'm going to start at 0 here, and I want to draw a horizontal line here, and then I want to draw another diagonal, another horizontal line, another diagonal. Heating curves are always going to look this way, kind of like a stair step, and each of the different segments of the line represent something occurring due to thermal energy absorption occurring. So when I'm looking at my heating curve, the axes are pretty important. So we need to label those. So on this axis, I'm going to write temperature, and I'm going to abbreviate with temp. And then in parentheses, I'm going to put degrees Celsius, like that. And then across the bottom, I'm going to put heat absorbed. So what I should be noticing as I'm looking at my heating curve before we label anything, I should notice that as the temperature increases, the amount of heat being absorbed is also increasing. I should see my most kinetic energy up here and my least kinetic energy down here. So let's label what all these little segments mean on our heating curve. So let's start down at the bottom, down here. This is going to be our solid. So when our substance, say we're talking about water, when our substance is in the solid form, it's going to be this diagonal and it's going to stay this way until it melts completely. So I'm going to write melt here on this horizontal line. I'm going to write liquid on the diagonal. On the next horizontal line, I'm going to write evaporate. And on the last diagonal line, I'm going to write gas. So I've got my solid, liquid, and gas on my diagonal lines, and I've got my changes as it changes from one form to another. I've got what those changes are called, melting and evaporating. You will dig into more about this as we go and talk about heating curves in class, but for now, have this as a point of reference. Let's go on to cooling curves. So let's draw our cooling curve first, and I'm going to use blue. So we want to first label our axes. So on this axis, we are again going to write temperature, and I'm going to again abbreviate that as temp. And I'm going to put my unit of measurement, degrees Celsius. And then across this axis this time, I'm going to write time. And I'm going to say this is in minutes. It'll depend on the curve that you're looking at. It might be in seconds, it might be in minutes, it depends on the curve. So let's keep going. We're going to start up here this time, and so I'm going to draw a diagonal line, and then a horizontal one, and then another diagonal line, and then another horizontal one, and then another diagonal line. And I'm going to take it all the way down to the axis. So let's label these parts. Typically, your cooling curve is going to look a little more even, like our heating curve did, but I didn't draw it as evenly as you'll see it in diagrams on sheets that we'll work on. So let's go ahead and do this. We're going to start up at the top with our highest kinetic energy, our highest temperatures. We know this is going to be gas here. When I'm looking at this horizontal line, we'll come right back to that in a second. This diagonal line here is going to be my liquids. And then my last diagonal line is going to be solid. So I've got my 3 states of matter. Notice they are in the opposite order as my heating curve. As a cooling curve cools down, the molecular motion is slowing. I'm going to see that it moves from my fastest, the gas state, all the way down to the slowest moving, the solid state. So as the gas changes to a liquid and it's beginning to slow down, I'm going to draw a little arrow here. And we know this is going to be called condensation. And then if I'm looking at my liquid, so say that I have a liquid form of water and I want it to cool down in order to turn into an ice cube, I know that it needs to freeze. So as it changes from a liquid to a solid, I know that that's going to be that freezing point that occurs. Again, we will dig more into the analysis of these kinds of curves, but I want you to have a point of reference to look at in the event that you can't remember where a particular state of matter or phase change occurs. So let's look at our overall standard one more time. And if we're looking at our standard overall, we can see that as we analyze and interpret the data of these types of curves, we're able to see the phase changes occurring. We're able to talk about the flow of energy, whether it's an increase or a decrease in energy. And that's everything that the standard is asking you to do. So that's everything I have for you today. If you need to pause the video in order to write any of this down, please do so. Have a good day.